your group work for just a moment here. Alright, so first thing is, if I need to know when this is increasing and concave up, I'm going to need first and second derivative. And I just started off with the first derivative. I'm going to go ahead and distribute this though. How did I get the first derivative so quickly? Right, this exact same function, we found the derivative earlier, so feel free to steal from that. So if I just care about where is it increasing, first derivative is fine. Looks like he equals 0 at x equals -2. It makes the numerator 0. And x equals -3 makes the denominator 0. Makes your whole fraction 0 or undefined. So -2 is a critical number. -3 is a critical number. So I could test something like 0 into the first derivative, and I would get positive over a positive. Could test -4, and I would get a negative over a, what's -4 plus 3? What's the square root of, okay, and where does imaginary number show up on a graph? Which means that part of the graph is not going to exist. Feel free to graph this in your calculator to see what I mean. It doesn't start until x equals -3 or up to it. And then trying to plug in a number between these is a little bit harder without a calculator, but it's not terrible. If I plug this in, this is going to be a little bit less than -6, so this makes the numerator negative. Plug it in here, I get something positive. Negative divided by a positive is negative. So, are you guys okay with the increasing, decreasing part of it? Okay. But this question, a little bit harder because it also wants us to pair that up with not only where is it increasing, but where is it also concave up. So, we would need the second derivative to determine concavity. So, if you have it written like a nice big fraction like this, it's a little bit easier to do the derivative of. It's got to be quotient rule here. Save myself some space. So derivative of the top with the bottom left alone, then minus the top left alone times the derivative of the denominator. So if I bring this 1/2 down, 2 times a half becomes 1. And then this becomes x plus 3 to the -1/2. And I'm going to move that to my denominator. Are you okay with that? You had denominator in your second derivative? Okay, well, when we have a smaller fraction within a bigger fraction, usually the way we want to move forward, this is called the complex fraction. I would really love to multiply this by the square root of x plus 3 because it makes that cancel out. But you can only do that if you're willing to multiply every term by the square root of x plus 3, which sounds bad, but it actually makes some stuff cancel out nicer. We've got a 6 here. Square root of x plus 3 times the square root of x plus 3 is just x plus 3. So I've got 6x, if I distribute 6 times 3 is 18. These two cancel, so minus 3x minus 6. And in my denominator, I don't know, this is a big mess, but it's not really going to help to simplify this. So really this stuff becomes 3x plus 12 in the top, or 3 times x plus 4 if you'd rather. The denominator is just going to have all of this stuff. But now that I've got the second derivative as a fraction, I can see that the numerator equals 0 at -4. So -4 is a possible point of inflection. The denominator equals 0 at -3 here or -3 here. So -3 is also a possible inflection point. That's the only two places the concavity might be changing. We plug in something like -5, makes the numerator 0, makes the denominator not exist, so I guess that doesn't help. So there would be no concavity over there. That makes sense. I guess the graph doesn't exist there. We said that earlier. Try something like -3.5 into the second derivative.
Is there even -3? Because previously our graph didn't expand past -3.
Yeah. What did I do here? Yeah, so it's not gonna, this doesn't exist either. And I didn't catch that on my work, but I can't take the square root of a negative here. If the graph, if it doesn't have a second derivative there, then the graph's not existing there. But why did I test some different numbers there? Okay, so I guess I should have tested over here like -2. I needed a point over here anyway. So this would become positive over positive. This is positive. This has to be positive because it's squared. And this would be positive, so concave up. So it looks like he's concave up from -3 to infinity. But it was increasing from -2 to infinity. So where is it increasing and concave up? Yeah, -2. So definitely a little bit harder because you did have to use quotient rule. You also had to practice simplifying this so that you can work with it. But one thing about this question though is many times you guys have been asked to get a common denominator to push fractions together, and that's always been to simplify your work. But this is the first time where you really kind of needed to do it for your own usefulness.